Good afternoon.
Hi.
So how do you like Colorado's monsoon season?
Yeah, it's kind of new for me.
I'll tell you what, it's new for us. I never remember this kind of rain at this time of year around here.
Mhm.
But yeah, it's a good day to be doing it online and not have to be out driving around.
Yeah.
Okay, so you have a session scheduled for today at 1, another one at 5, and then
Just at
another.
one. I had to change it because I had to. That's the one I changed until now. It should be changed because I had to go to choir audition.
Okay, let me change that while I'm thinking about it.
Yeah.
Um, I usually have to close out all these because it overloads my computer when I run these other
Yeah.
applications.
The screen is also a little smaller because your webcam is on.
Okay, first of all, let me cancel the one at 5. Okay, now I can close that. And you still want the one tomorrow at 11?
Yep.
Okay, let me close this out. And I'm kind of curious, does that affect anything having my webcam open? Can you
It
see
just goes
these
a little bit
questions?
slower. I can see them. It's just smaller.
Okay, now let me close my camera out. Does that make a difference? That's
Yeah, it
better.
makes it bigger.
Wow, okay. Well, I'm going to have to adopt the Sal Khan philosophy totally, I think, which is to not put the webcam up and just do the audio. Okay, let's pick up with circles. We finished quads.
Yes.
So can you see this first question? What's the circumference of a circle whose area is 100 pi?
What is, well, the formula for circumference is 2 pi r, right?
Correct. What's the formula for area? Because those are the two big ones.
Pi r squared.
And that's the only two you really need to know.
Mhm.
Okay, so how do we answer this question?
Well, you say that 100 pi would be,
Go ahead. I know you want to say it.
well, radius is equal to 10. So it's pi 10 squared.
Okay, let's go back to this first equation.
Well,
Circumference
it's big.
equals 2
Yeah,
pi
but
r. So
yeah, but
100 pi would equal to 2 pi r, right?
no, because it says the area is 100 pi.
Oh, excuse me, my mistake. Okay, so we're going to do this. Equals
So
pi
wouldn't it
r
be,
squared.
so
Okay.
r is equal to 10.
Right. And then what is the circumference if r is equal to 10?
20 pi.
Okay, good. These two formulas pretty much govern circles, everything you need to know about circles that they're going to ask you.
Well, then that's good. I know them.
Okay, good. Let's leave them up there, but well, let's erase them so that you'll rely on your memory. Okay, what's the area of a circle whose circumference is pi?
So pi is equal to 2 pi r.
So what's r equal to?
1.
1/2. In other words, we have to divide both sides by 2 to isolate r.
Okay.
Okay, so now what is the area of a circle whose radius is 1/2?
Pi r squared.
What's that equal to?
Well, I mean, a half times a half is a fourth.
Okay, so that's the answer. In other words, we square the numerator, we square the denominator, so this is the same thing as this, but
Yeah.
they show it as this, so we have to recognize that as the same thing. Okay.
Yeah.
It's the area of a circle that is inscribed in a square of area 2. Now here terminology might be a little critical. A circle that's inscribed in a square is this kind of a circle.
Ah, okay.
A circle that, or a square that's inscribed inside of a circle would be that. So it depends on which way you're going. But in this case, the circle is inscribed in a square, so we don't need this one. And the area of the square is 2. So what does that tell us? What's S?
Well, we have to have two equal numbers that multiply into 2.
Well, how do we solve for S? In other words, if the area of the square is equal to 2, and that's equal to S squared, because the area of a square is the side length squared.
You take the square root of 2, which is 1.4.
Well, let's leave it as square root of 2. It's always more accurate to leave it as square root of 2 than it is 1.41. Okay, so that's the side length. Now let's look at the circle. What's the radius of that circle?
It's half of square root 2. Or, yeah, it's half of square root 2.
Which is that. So now what is the area of the circle?
And that is pi radius. So it's, yeah, what you're writing.
Okay, and then what is that equal to?
Pi square root 2.
Well, square the numerator and the denominator. What's the numerator squared?
The numerator squared.
What's square root of 2 times square root of 2?
2.
What's 2 times 2?
4.
There's our answer.
Because that's 1/2, and then you put the...
It's 1/2 pi, or pi over 2. Okay? The square of area 2 is inscribed inside of a circle. What's the side length of this square?
Square root 2.
we know that to figure out any information about the circle, we need the radius, right?
Mm-hmm.
There's a radius. Can we figure out what r is?
You can turn it into a triangle.
Okay. So if we look at that triangle there, we know it's 45, 45. Hold on 1 second. Okay, excuse me. So if we're looking at a triangle that's 45, 45, whose side is square root of 2, what is the hypotenuse?
2 square root 2?
Well, let's see. If we look at our normal one, it's 1, 1, square root of 2. So our ratio is square root of 2 to 1. So our hypotenuse is square root of 2 times square root of 2. So this must be 2. Now, do you see how I did that? Because this is a harder one to do.
Yeah.
In other words, this is a similar triangle problem where we're comparing this 45-45 right triangle with this 45-45 right triangle. And I know you use x's there instead of just the numbers. But the key is, what's the ratio? The ratio, how much bigger is this triangle than this? Well, it's square root of 2 over 1. Because we're comparing the square root of 2 side with the side that's 1, which means the hypotenuse has to be this ratio times this hypotenuse, which is square root of 2.
Yeah.
So that's how we get 2. Okay, so if the whole thing is 2, what's the radius?
1.
And what's the area?
Pi.
Correct. C. All right, let's skip 5 and go to 6. Now, there's actually 2 main things you have to know about circle. One we just covered, which was all questions regarding circumference and area. Well, these questions regard sectors, and another question might ask about arc length. And both of these questions are still depend on the area and circumference formulas.
It's the n divided by 360 and then multiplied by either the area or circumference.
So it's W divided by 360.
Yeah, in the book it's n.
Okay.
That's why I said n.
So this is a shaded area. So the shaded area is 85%, so W is 15%. So really we're going to multiply 15% times 360, which is 36 plus 18, which is 54. So W equals 54 degrees, and that's what they're asking about.
How did you do that? I'm sorry, I'm confused.
Oh, that's okay. And the area of the shaded region, which is this part, is 15.
I got so far. I just didn't know how you put up the formula. So you said W divided by 360 times 15 times 360?
Well, not really. What I ended up doing is that if I know that this is 15% of the area, and I know that W is 15% of 360, right?
You just did a normal percentage.
Yes. Just multiplied 15% times 360 and got 54 degrees. Straight away.
Oh, okay. It was just, I think I got confused because the other parts stood there. And
I understand that. Usually when you have a area of a shaded sector, you end up doing the ratio. But this was a little different. This was actually a little more straightforward and easier. Okay, how about number 7?
The circumference of a circle is a pi, and the area of the circle is b pi. If a equals b, what is the radius of the circle? Wouldn't you just have to pick some numbers or do back solving?
You could do this a couple of ways. If, first of all, what's the formula for circumference?
2 pi r.
And area?
Pi r squared.
Well, they're saying if A equals B, then this equals this. So 2 pi r equals pi r squared. And now we can solve for r. If 2r equals r squared, then 2 equals r. There's your answer.
R divided by r, like r squared divided by r, automatically just gives r.
Yeah, as long as you're sure that r can't be 0, that's an okay way of solving it. The best way to really solve this equation is to subtract 2r from both sides and solve for r, and you get r can either be 0 or r can be 2.
Okay.
Okay? But since they're asking for the radius of a circle and they don't give you 0 as an answer, 2 has to be our answer. The key is if you know A is equal to B, then we know that that is equal to that. And since that is that and that is that, we can set that equal to that.
Okay.
Okay, this is a more typical problem that I thought we were dealing with before. Okay, they want the length of this arc.
Well,
This is really a circumference problem.
yeah, what I wrote down is I have 144 divided by 360 times 2 pi r.
Right, times the circumference, which in this case is 20 pi. That's 2 pi r. So,
Oh, there's a 10. Sorry, I didn't see that.
no, that's okay. So that's 2 pi r. So if we're reducing this, I can do this. Now I have 144 over 18 pi. And that looks like 8. 8 pi.
Well, I got the formula down, so that was fine.
Yeah. Yeah, this is really a circumference problem, and knowing that this is 144 over 360 of the circumference. So what's the area of the shaded region? Similar.
It's 144 divided by 360 times 100 pi.
Okay. Now I can do that. And now I have what? 1440 divided by 36 pi. kind of answers are we looking at? Must be 4. 40 pi. In other words, I don't even have to do that math. You see why?
You just see the answers.
If I'm looking at these answers, I can tell that it's not 20. It's got to be 40. In other words, you can take certain arithmetic shortcuts if you're looking at the answers, and we know, well, this 1440 divided by 36 is certainly more than 2. 36 goes into 144 more than 2 times, more than 20 times. So I know the answer is 40 instantly.
Yeah.
Even though this is different, what is x? This is an important principle, I think.
One second. Can I try and calculate it, see what I get?
Sure. This relies on a principle that you kind of have to recognize.
$54?
Yes. In other words, you know that all radiuses are equal. So this is an isosceles triangle. So whatever that is, that's the same thing.
So I just said 180 divided, like minus 72 divided by 2.
That's it. Okay, good. Number 11, I'm missing the E part, but that shouldn't matter. We should be able to do this even without multiple choice.
If A is the area and C the circumference of a circle, which of the following is an expression for A in terms of C?
Let's start with what A is equal to and what C is equal to.
Well, A is equal to pi r squared, and C is equal to 2 pi r.
Okay, now how are we going to relate A in terms of C?
I'm not really sure what that means in English.
Okay, we can do it a couple ways. If we solve the second equation for R, we get R equals C over 2 pi, right?
Mm-hmm.
Now if we go back into the first equation and use this for R, now we have A as a function of C, which is what they're looking for. In other words, if we look at all of our answers, we have A is equal to C is in the right side of that equation in all of them. So all we have to do is simplify this and we'll have our answer.
Mm-hmm.
What is that simplified?
Well, it's pi, and then it's C squared divided by 4 pi
4
squared.
pi squared, right. Okay, now simplify that.
C, oh,
Do you see how I canceled 1 pi with one exponent?
but wouldn't you still have C squared?
Excuse me, I didn't see that too. Yes, you would.
Okay.
Thank you. So what is that? That must be A.
Yeah.
Okay? So when they say they want A in terms of C, they're basically saying they want A as a function of C. Normally, A is a function of R, and C is a function of R. So the other way I could have solved this was I could have solved each of these for R and then let one equal the other and solved for A, and I would have gotten to the same spot. Although I think this way actually was a little quicker, the way we did it. Okay. Let's see, we've done that one, we've done that one. Good, there's not very many on this page, which is good because I didn't photograph it very well. What's the area of a circle? You can see that every single question we've had has required you to know those area and circumference formulas. What's the area of a circle whose radius is the diagonal of a square whose area is 4? Let's draw the square. Area equals 4. What's the side length of the square?
It's 2 and 2.
And so the radius of the circle is the diagonal of the square. So what's the diagonal of the square?
It's 2 square root 2.
And that is equal to the radius of the circle they're talking about. And they want the area of the circle.
Well, 2 squared. You do both numbers, right?
Correct.
So that's 4. And that's 2.
Okay?
And then do you multiply those?
Yes.
Yeah, so
In other words,
it's
it ends up being 4 times 2.
So it's 8 pi.
8 pi. Okay. All the rest of these are quantitative comparison, which we're not doing. So let's go to the next geometry section, which is solid geometry. Three-dimensional geometry. I need to blow it up a little bit bigger than that. Let me use my mouse. Okay. All right. The sum of the lengths of all of the edges of a cube is 6 centimeters. What's the volume in cubic centimeters of the cube? Here's our cube. And they want the sum of the lengths of the edges. Well, we have an edge there, 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 there. How many edges do we have in total?
I
think we have 12. I think we have 4 on that face. We have 4 on the face behind it. And then we have this one, and we have this one and this one here. So I think we have 12 edges on every cube. So if the sum of the edges is equal to 6, what's one edge?
Two.
If one edge was 2, the sum of the edges would be 24.
Okay, I'm not sure I understand the question.
Okay, they're saying if each one of these edges was 2 and I had 12 of them, the sum of the edges would be 24. So if the sum is 6, each one must be 1/2.
Oh.
In other words,
Yeah.
that's 1/2, that's 1/2, that's 1/2, and then 12 times 1/2 would be 6. So if the edge of the cube is 1/2, what is the volume of the cube?
I can't remember the formula, so 1 second.
It's all three dimensions times each other.
Length, width, and height, right?
Right. In other words, if I want the area of a square, I do length times width. If I want the volume of a cube, I do length times width times height. And in this case, they're all 1/2. So what's 1/2 cubed?
Mm. 3/4.
Let's do 1/2 times 1/2 times 1/2.
Oh, it's an 8.
All three numerators multiply, all three denominators multiply. So it's A. I think 2 is worth doing, even though it's not a multiple choice. It still covers math concepts that you need to know. So we need the volume of a cube whose surface area is 150. How many surfaces are there on a cube?
6.
Okay, so what's the surface area of each face?
$25.
So if this is 25 and this is 25, what is one side of the cube equal to?
Oh, one side? 5.
Now we have all we need to figure out the volume. What's the volume of this cube?
125.
Right, because volume equals side cubed. Okay. What's the surface area of a cube whose volume is 64?
Well, the side is 4.
Okay. What's the surface area if the side is 4?
Um, 96.
Because each face would be 16, and there's 6 of them. Okay. Good. Seems like you know your solid geometry pretty good. What is the number of cubic inches in 1 cubic foot?
Oh, gosh. Well, okay. Would it be, well, if there's 12 inches to 1 foot.
Okay.
Right?
So the number of cubic inches, what I've drawn here is a cubic foot. Right? Because it's 1 foot by 1 foot by 1 foot.
1 foot.
So how many cubic inches is that?
$36.
It's length times width times height.
Oh.
12 times 12 times 12. What answer is that?
That can't be right. Well, 12 times 12 is 144.
Okay. So it's got to be this one.
Yeah, the 1,000 one.
And that is right. There are 1,728 cubic inches in 1 cubic foot. In the same way, notice that there's also 144 square inches in 1 square foot. So this is that same principle we were talking about last time, where the linear relationship gets squared when you go to area, and it gets cubed when you go to volume.
Yeah.
So even though it doesn't sound like it makes sense that there could be 1,728 cubic inches in 1 cubic foot, there really are. In other words, if I were to go to this cubic foot and I were to have a bunch of Tinker toys that were each 1 square inch cubes, and I were to pile them, try to fill my box with these 1-inch cubes, I would be able to put 1,728 of them inside that box.
Yeah.
Okay. Okay. Another cube. They're big on cubes.
Okay, so a solid metal cube of edge 3 feet.
First of all, let's draw our rectangle. There's our rectangle. This rectangle is 3 by 4 by 5. And they're saying that if we place a 3 by 3 by 3 cube inside that thing, not a very good artist, unfortunately. Let me see if I can do a little better job than that, though. Yeah. There's our cube that's placed inside the metal box. What is the volume in cubic feet of water? What in the world? Let me read this again. Okay. If they want to know the volume of water that the tank can now hold, this is a shaded area problem, right?
Yeah, it's... Okay,
shaded area problems are what kind of problems?
Well, it's subtract problems.
Okay, so what's the volume of the full rectangular box?
60.
What's the volume of the cube?
27.
There's our answer. So I really didn't need to draw a picture. That was kind of wasted time. If I'd have read the problem more carefully before starting, I probably would not have taken the time to draw the picture, because I would have recognized that it's instantly a shaded area or a shaded volume problem. So it's strictly a subtraction problem, and it's really rather simple. 3 times 4 times 5 minus 3 times 3 times 3.
Yeah.
As a tutor, I have a hard time helping myself when I instinctively draw a picture, but you don't always want to do that. That was a good example of it. Let's do 6, which is kind of a tough problem, and then we'll go to some test questions. This one might be hard for you to understand, just from terminology point of view. Here's my cylindrical pipe. It has an outside radius and an inside radius. Okay, so imagine a piece of pipe. It's open to, this is air here, and the outside radius is, well, first of all, this is 5 feet long, has an inside diameter of 6 feet, an outside diameter of 8 feet. So that's 8 feet, and that's 6 feet.
So the long diameter is 8 and the other is 6.
Right, so the radius is 4 versus 3. Now, if the total surface area, inside and out, including the ends, is k pi. What is the value of k? This is a particularly difficult question, but doable. Let's talk about the following problem first.
Wouldn't you have to get the volume of this thing first?
Let's look at a right cylinder. You know what I mean when I say a right cylinder?
Mm-mm.
What is an object that is shaped as a right cylinder? A tin can.
Okay.
Okay? If the tin can was a can of soup and it had a label on the outside of it, and I wanted to know the area of that label, how would I get it? Let's say this tin can has a radius of 3 inches and a height of 5 inches. What is the surface area of, it's called the lateral surface area? How would I get it?
1 second. That's not it. That's not it.
If I unfolded that label, it would be a rectangle, right? If I unwrapped it, if I unpeeled the label off of the soup can, it would be a rectangle whose height was 5 inches. What is its length?
What's the radius?
It's the circumference of that circle.
Okay, yeah.
So it's 2 pi r. So it's 6 pi. So the area would be 30 pi. So if I'm looking for the area of the lateral surface area of a cylinder, I have to use this logic. I have to know that the area is the height times the circumference of that circle that makes up its base. So let's go back to our original problem, which is all about surface area. So what's the outside surface area on this pipe?
It's 5.
The radius, okay, it's 5 times what?
It's 5 times 2 pi 8.
4, because the diameter is 8.
Oh, 4, sorry.
So the radius is 4. So the lateral surface area of the outside of this pipe is 40 pi.
Yeah.
What's the lateral surface area of the inside?
That's 5 times 2 pi 3.
Which is 30 pi.
30.
Now that would be the inside and the outside, but they want the ends also. So we have 2 of these. So what's the area of one of the ends, the shaded region? And notice that they do put 70 as an answer.
Well, you would have to take the area of both circles and subtract them.
Let's do it. What's the area of the outside circle?
64 pi.
And the inside circle?
36 pi.
What is that? 28 pi. That's this area is 28 pi. We also have the other end of the pipe. So that's another 28 pi. So that's 56 pi. Wow, that's amazing that the surface area of the end pieces is actually greater than either the outside or the inside.
Yeah, and then you put all that together.
126 pi. So that should be the total surface area. Ah,
Mm-hmm.
we did something wrong. That answer's not on there.
Yeah. Well, if they want including the ends, why are we subtract?
If we subtracted, what would we get? 14 pi? That's not on there either. Let's see. 64 pi minus 36. Ah, it's not 64 pi. The ends are not that. We got that wrong. The outside circle is a radius of 4, so that's 16 pi. The inside circle is a radius of 3, so that's 9 pi, so we got 7 pi, which makes a lot more sense. It didn't seem right that that area was that much greater than that area.
But we don't have 77 either. That's not an answer either.
Because I didn't multiply it by 2. There's this end of the pipe, and then there's the other end of the pipe. So it's 14 pi.
84.
So it's 84 pi. Like I said, that was a tough problem. That's probably as tough a geometry problem as you're going to get.
Mm-hmm.
All right, let's do some, see if we can find some data sufficiencies. So we went through 6. And let's open this. Last time we got through number 25, so we start right off with the data sufficiency.
Yeah. Is the area of a quadrilateral R greater than the area of quadrilateral S?
Call that one R. Call that one S. Which statement is easier to consider?
The number 2.
I always go with the shorter one.
Well, just because you know that R and S are both squares, that doesn't say anything about whether they're one is bigger than the other, because you don't know anything about the sides or anything.
Exactly. So 2 is a resounding no. And that's why I like to consider the shorter, simpler statement first, is because frequently we can instantly answer that.
Well, 1 is also no. Because it just says that the perimeter of R is greater than the perimeter of S. But since we don't know if they're square, if they have like 90...
One could be shaped like that, the other
Yeah,
could be shaped like this.
that.
Whereas
So,
this perimeter is longer, same areas, so you're right.
mhm.
Just because the perimeter is greater says nothing about that. So 1 alone is a resounding no. Now how about both together?
I would say yes, just because if you know they're both squares, and one has a bigger perimeter than the other, means that the sides are longer, which would give it a big an area.
That's exactly right.
So the answer is C.
Uh-huh. Okay, these are problems that I call symbol problems.
They're like functions, right?
Kinda. They are like functions, only they make up symbols. These are not mathematical symbols recognized.
Yeah, exactly.
So they're saying that if x square y means this function, x times x minus y, then what is minus 1 square minus 2 square 1 square 2? So you have to go through each one of these. These are actually very simple problems. You should never really miss one of these. They can be a little time consuming. But let's go through. What is minus 1 square minus 2?
That's minus 1 parenthesis -1 minus -2.
Okay, let's simplify that number. What is that going to be equal to?
Well, -1, that would be 1. So it's -1 times 1, which
Okay,
is -1.
so that thing there is -1.
Mm-hmm.
Let's figure out what 1 square 2 is.
So that's a 1 parenthesis 1 minus 2, which is -1.
Okay, so now we have to figure out what -1 square -1 is. In other words, what is -1 square -1?
Yeah, so that's -1 parenthesis, -1 minus -1. That's 0.
Good. Very good. It's clear that you know how to do symbol problems. And they're just substitute and solve.
Mm-hmm.
That's probably as complicated as one that you'll see also.
Mm-hmm.
Data sufficiency. Minor arc AB is the degree measure of that. Something between 0 and 360 degrees.
Mm-hmm.
What's the simpler statement to analyze? Okay?
Well, you can't figure it out with that one.
Well, if this angle is 60 degrees,
Well, isn't it
excuse me. Well, OAB is 60, but
so
since
it's
all
A
radii are equal, this is also 60, and that would also be 60.
Oh, yeah, okay.
In other words, that
Well,
would have to be an equilateral triangle,
Uh-huh.
which makes this arc equal to
360.
60. This arc
Okay.
is always equal to whatever this angle is.
Mm-hmm.
So if we know this angle is 60, which we now know, then this arc is 60. So 2 is a yes.
Mm-hmm.
Now how about 1? The length of line segment AB equals the radius of the circle.
That's a no, because you don't know what the radius is.
Well, I know that this radius is equal to this radius.
Mm-hmm.
And if they tell me this is equal to both of this, that also tells me I have an equilateral triangle because I have 3 equal sides.
Yeah, but there's no numbers or anything.
Doesn't matter. If you have 3 equal sides of a triangle, it has to be equilateral, which means you also have 3 equal angles, which means each angle is also 60 degrees. So statement 1 essentially says the same thing that statement 2 does.
Okay.
So it's a yes. So the answer is D, either one alone. Okay, you good with that one?
Yeah.
Okay. I seem to remember this one from a couple years ago. Let me think. Okay, let's end our session with this one. This is a pretty hard one also, if I remember right. Maybe not.
Okay.
Maybe not.
In a horse show, 9 of the horses competing were awarded ribbons. The show's judge never awards ribbons to fewer than 15% of the horses, and never to more than 30% of the horses. If H is the number of horses competing, how many different values of H are possible?
Okay, this wasn't as hard as I had thought it was.
Well, I mean, you start with 100%, right?
Let's figure out what H could be. He only awarded 9 ribbons. So there's at least, in other words, if we solve this as we would a typical algebra word problem, and we let H equal the number of horses, then what can we say? We can say 15 of H is the low end of our spectrum, and 30H is the high end. So let's back solve. Hold on a moment. If H is the number of, how many different values of H are possible? Well, we know he awarded 9 ribbons. So what's the highest possible value of H, if that's equal to 9?
That'd be 9 divided by 15 times 100.
Which is 60. In other words, H could be as high as 60. He could have awarded 15% of 60, which would be 9. But it could have also been a number where 30% of the horses would be equal to 9. And in this case, H is equal to 30. So we have a situation where the horses could be anywhere from 30 to 60 horses.
So that's 30.
Exactly. Well, or is it? Is it 30 or 31?
Well, it would be 31 because it's the number included.
Yes. Do you work with spreadsheets?
Not really.
Well, if I said how many rows are there between row 3 and row 97, including both of those rows, the answer is 94 plus 1. In other words, if you're including the two numbers, and in this case, it could be 30 and it could be 60. So we have to include both of those, so the answer would be 31, not 30. It's the same problem. This is a frequent problem, whether you're dealing with the rows of a spreadsheet or people standing in line. Say you have 20 people standing in line and one person is in position 3 and the other person is in position 16.
It's the same thing. It's the same thing as also saying like how many numbers between this and this number is a multiple of 3 or a multiple of 5.
Okay. Yeah. The key is not to just subtract these two numbers. But in other words, if I said how many rows do I have between row 1 and row 2, well, if I subtract those, I get 1. But in fact, I know there's 2. There's row 1 and row 2.
Well, you subtract them plus 1.
Exactly. Or if you don't want to count either one, you subtract them and subtract 1. In other words, if I said Bob was 3rd in line and Mary was 8th in line, how many people are in between them? It's 8 minus 3 minus 1, because you're not counting either of them. So it's that principle, but that's a principle that the GMAT likes. You're going to see that in questions for sure. This being one of them. Okay, so let's see. I'll talk to you at 11 o'clock tomorrow morning, right?
Yep.
Sounds good.
Perfect.
Have a
Thank
good
you so
evening,
much.
Cecilia. Were you named after the Simon and Garfunkel song? I'm just curious.
No, I'm not.
No.
Actually,